The first rumor is in the numbers, a scatter of points on a graph where distance marries velocity, where a faint traveler writes its presence into our observatories as a signature of refusal to be owned by the sun, refusal to turn back, refusal to obey anything but the grand geometry of the galaxy. You can almost hear the quiet in it, a vacuum hush around a sleek body that has learned the cold patience of interstellar night. Its path is a line taut as a bowstring across the fabric of our planetary stage, a trajectory whose curvature is too slight, whose energy is too large, whose eccentricity is too proud to kneel to any orbit at all. We point mirrors and cryogenic sensors into that darkness and ask a simple question: what or who holds this arrow steady? Astronomy is a craft of suspicion and humility. The sky plays by rules, the inverse square law of gravity, the thermal tremble of black bodies, the chemistry of light etched into spectra like fingerprints. And yet, behind those rules, there is often an arrangement we did not expect. We measure brightness and watch it flicker as the object turns, as if a faceted artifact is rotating, or as if ragged surface slopes breathe sunlight with every spin. We time the flashes and infer a period. We nudge the data with models of irregular shapes, and everywhere we test the fit, there is that small, clean remainder, a residual in the motion that whispers of a pressure other than gravity. Is it outgassing, the ghostly exhale of volatile ice sublimating in the warmth of our star? Is it radiation pressure, the tender shove of photons on a thin, fragile sail? Or is it something narrower, needle-precise like microthrust from a guidance system that slept for 1,000,000 years and woke with a single instruction to angle toward a particular geometry of worlds and light? They called it Three-Eye Atlas in the language of catalogs and survey, which is to say, the third interstellar visitor, traced with enough conviction to be named, flagged by the wide-field patient heart of a robotic sky. The number is simple, but the meaning is immense. Once is anomaly, one eye, a shard from elsewhere. Twice is pattern, 2i, a comet that wears the accent of other suns. Thrice is the beginning of a census, and with a census comes the freedom to compare, to weigh, to say this one is like that and unlike the other, to ask which family the universe has placed the new arrival in. On this foundation, caution becomes a ladder rather than a cage. We climb it gently, rung by rung, toward an audacious thesis. Perhaps this is not debris, but design. Perhaps this is not merely the broken-off leftover of a turbulent protoplanetary childhood, but a deliberate instrument, an arc seed, a probe seed, a geometry of purpose, slow as continents, but stubborn as life. The light it returns is thin, silvered by distance and diluted by the scattered glow of interplanetary dust. Photometry can be treacherous, and yet it tells stories if you listen long enough. The curve brightens, dims, brightens again, as though planes are catching sun, then falling into shadow, then flaring with a specular wink. The spectrum sits close to a carbonaceous hush, a not-quite cometary darkness with a matte finish, the sort of surface that drinks photons and gives you back a modest albedo as an answer. Embedded in that reading is temperature. Embedded in temperature is an inference of composition and texture, porous aggregates, fused grains, a crust sealed by the ancient bake of cosmic rays. We check the astrometry, those precise pinpricks of position against the backdrop of fixed stars, and we solve for a velocity at infinity measured in dozens of kilometers per second, a permanent dowry of motion inherited from some cloud and star we do not yet know. No prayer to Jupiter will capture it. No magnet of solar gravity can do more than bend it. The mathematical verdict is blunt, unbound. But it is the deviations that magnetize the mind, the slight tug in the residuals that refuses to vanish when you subtract every known force. Build the model, sun plus planets, add radiation pressure, add solar wind, add the faint hiss of outgassing if any ice remains. fit the trajectory, subtract. What's left is a breath of acceleration with a stubborn sine and a repeating angle, as though a flat plane is turning to meet the light at regular intervals. Natural objects can do this. Comets do, shards do, but natural objects rarely maintain it with such consistency over such a time without advertising jets, dust, coma. Here the coma is a rumor at best, the tail a smudge that loses its courage in the noise. A thin sail, however, would not need to boil its own propellant. It would need only a star and a plan. And a seed ship, if such a phrase can live in the mouth of science without immediately burning it, would need a durable logic, not fast thrust, but patient vectors, tilt here, absorb there, correct the line by microns that become thousands of kilometers downrange. Sober minds police themselves. They bring and counterexamples like guardians. Could the non-gravitational term be thermal? The Yarkovsky effect can push an asymmetric body slowly by the recoil of heat, a medieval incense boat drifting on currents of its own perfume. But Yarkovsky requires spin, and spin requires time, and time requires a shape arranged so that the afternoon side always gives a little more sigh than the morning. Do we see this in the light curve? Does the phase function match the push? We test and test again. Could it be a porous flake, a fractal snow of dust compacted into a quasi-sail by its accidental architecture? Possibly. Nature sometimes accidentally invents small wings that ride worlds of light. But again, the persistence bites. The vector holds steady. The adjustments are too disciplined, and physics, while generous, is not infinite in its coincidences. This is where the dreamers look up from the lab bench and say gently that a hypothesis is not a marriage vow, it is a tool. And one viable tool, given the data, is intention. If intention is a bridge too far, walk up to its edge and consider what stands there. A seed ship, not in the cinematic sense of engines blazing and flags snapping, but in a botanical sense. Not a colony ship full of cities, but a kernel. Consider that civilizations more patient than ours might sow their galaxy the way alpine flowers cast seeds uphill, by waiting for seasonal winds they do not control, by designing tiny aerodynamic truths into husks and wings, and by trusting statistics. Launch 1 trillion, watch 1,000 survive, watch 10 wake. A stellar seed ship could be a wafer of materials that sleep as glass sleeps, torpid biochemistry held in a crystalline matrix, or patterns of DNA and memory encoded into error-correcting molecules. It could be an AI so small it is almost an equation, frozen into a semiconductor that thinks only in bursts when heat permits and photons power it. It would cross the gulfs not in centuries but in eons, immune to boredom, married to redundancy, accompanied by a flotilla of siblings. When a host star's spectrum warms it above a threshold, it would turn, feed on light like a desert lichen, record the local chemistry, and choose to pass through or choose to slow or choose to drop seeds of its own into promising wells of gravity. Timing sharpens this story. The object arrives when our detectors are waking into a new vigilance, the all-sky surveys fanning out with arrays of cameras that never sleep. Its path sketches an angle that offers us weeks of vantage instead of days. It threads a window between solar storms, dodges the geometric tyranny of conjunction just long enough to be seen clearly, then glides into glare when the data would matter most. None of this requires conspiracy. Probability is a long coastline. Even the strangest shell can wash ashore by honest tides. And yet, occasional alignments of timing, of brightness, of geometry accumulate like teeth of a key. A star's activity cycle opens. Our weather yields, the moon's phase dims, and for a brief corridor of nights, the skies conspire to place a thin visitor in our reach. Then, as if shy, it dissipates. Stars into the gabled light of the inner system, where solar corona and scattering air ruin our gaze. What are we to do with coincidence? Science does not dismiss it. It quantifies it, and still it leaves a taste. A path through a planetary system is a negotiation with giants. Jupiter, with its great slow hand, reaches to tug every traveler. Saturn lends a polite nudge. Even Earth paints ripples into the background. Three-body dances whisper into six-body murmurs, and the equations billow with chaos unless you hold them tight with computation. We integrate forward and backward, computing millions of futures and pasts, and in the family of solutions that match the data, a pattern emerges. Small encounters at large distances that add and subtract energy the way tiny waves can sculpt a coastline over millennia. If you intended to traverse a system without stopping, you might aim to skim these weak fields, to gather or shed a few meters per second in a sequence of nearly invisible kisses, a gravitational ballet that costs nothing but forethought and time. Our visitor behaves as though it knows this dance, not the brazen dive of a comet into Jupiter's grasp, not the careless weave of a fragment through Mars's loose fingers, but a subtle off-axis exchange that whispers efficiency. If it is a seed, it harvests curvature the way a sailboat tacks, cleverly, parsimoniously, with one eye always on the horizon beyond the next star. Then the blackout comes, and everything human in us flinches. Solar elongation tightens. The object crowds too near the sun in our sky to be tracked safely by most instruments. Spacecraft with coronagraphs can sometimes rescue data, but their time is rationed, their fields of view small, their primary missions off elsewhere among storms of magnetic fire. Ground telescopes drown in airglow and daylight. The pipeline of coordinates and brightness and spectral strokes dries to a whisper. Silence is a canvas onto which we can paint almost anything, and so restraint is required like oxygen. Yet, suspicion blooms in the vacuum. What if there were maneuvers there? What if the unobserved interval is the precise window in which the patient sail shifted orientation, in which a microvolt of seed chemistry woke for a minute to copy itself, in which a tiny bow shock of directed gas pressed the curve a little closer to some distant rendezvous? Perhaps nothing at all happened. Perhaps the object slept, turned, and continued into night beyond our glare. But the human mind, trained equally by science and myth, presses its face against the glass of not knowing and sees both angels and equations. When the object reemerges at an angle grayer and a magnitude fainter, we snap to. Observatories resume their watch. The curated trajectories we'd sewn together bloom into a new fit. Do the non-gravitational terms persist? Has the sign flipped with spin-state precession as a thermal model might predict? Or does a sail continue to meet the light in the same general canted embrace? The answers trickle, and with them a chorus of consequences. If the phenomenon is natural, it revises our inventory of interstellar debris, perhaps disks around other stars, shed rafts of low-density material that wander like dandelion seed heads. Perhaps planetesimal collisions in far-off systems favor flakes and foams over stones. If it is artificial or half-artificial, a natural body tuned by a thin film, a comet core stiffened by woven fibers, a shard renovated by physics to be a vehicle, then our engineering has found its first elder cousin. That knowledge would not be a blow. It would be a draft for the next century. Build lighter, think colder, aim slower in the short term to go faster in the long term. Teach small devices to suffer the dark without complaint and to drink light without waste. A seed ship implies something more subversive than mere travel. It implies ecological ambition at a cosmic scale, whether by biology, by mind, or by information that is both. Picture a seed that lands on a night side of a rogue world in a gas giant's shade where tidal heat and chemical gradients shimmer through subsurface brines. Picture it tasting water through pores, measuring salt by the way it freezes and thaws, listening to the crackle of radiation against its hull the way we listen to rain. If the measurements pass thresholds, it splits. One half becomes a recorder, anchoring to ice or dust. The other lifts, thinned to near nothing, to catch sunlight and whisper the news to any listening ear. Or picture it as a wandering library, inert until it reads the spectrum of oxygen and methane in tasks that should not coexist. Then it warms, and a chemistry older than planets starts to copy itself in slow mineral handwriting. In the cold genius of this concept, there is no drama. There is only statistics stretched across 100 million years, a botany of star fields. For our species, the implication is strange comfort braided with challenge. We have dreamt of starflight as fireworks, engines that rage, ships that sleep, awakened crews walking gardens under foreign suns. A stellar seed ship speaks a different dialect of ambition. It says that the galaxy is for patient farmers, that civilization can propagate not by conquering distances with violence, but by collaborating with the arithmetic of light. Light is not merely illumination. It is momentum available to those who learn to eat it. And mass is not a burden. It is a budget. The less you carry, the more cosmos you can afford. In a century, when our instruments grow eyes like dragonflies and our factories grow hands like spiders, we can imagine devices spun at scales that shame dust motes, with brains that are mathematics in a crystalline garden. Such devices do not fear centuries. They do not suffer boredom. They are close cousins to the quiet dignity of stones, but they are not stones. They are intention written so sparsely it looks like silence until you measure it the right way. Skepticism remains our North Star because wonder without discipline becomes superstition, and discipline without wonder becomes bureaucracy. In the end, the seed ship hypothesis must bow or stand by what it predicts. It predicts a relationship between brightness modulation and trajectory correction. It predicts a correlation between solar phase angle and non-gravitational terms that deviates from comets. It predicts occasional micro-events, thermal shifts, orientation pulses, at times when energy input peaks. We test these. We compare with a training set that now includes 2 earlier interstellar visitors with their own quirks and 1,000 comets from our home. We look for the family resemblance that would mark 3I Atlas as kin to a natural clan. If it is kin, the story remains astonishing. Nature has invented sails out of accident and ice. If it is not, then somewhere, sometime, someone chose this exact physics and sculpted matter to obey it. Sometimes at the edges of our maps, the difference between accident and art dissolves into a gradient finer than current instruments can resolve. But instruments improve. They always do. That is the invitation engraved in this passage of a dark pilgrim through sunlight. Build better eyes. Build them in orbit to dodge the breath and glare of our atmosphere. Build them in the deep night of lunar polar craters where thermal noise is quiet and stars are steady. Build them as small fleets so that when an interstellar stranger threads our sky again, we do not scrape for a week of weather and an inch of phase angle. We swarm it, send quick, clever chasers with microsails that can ride radiation pressure in the opposite sense and intercept in days, not months. Store small analyzers that can taste dust and sniff ions and photograph the texture of a surface that might be both rock and plan. The ambition is not just to answer the binary question, natural or not, but to become the kind of civilization for whom such arrivals are not emergencies but opportunities, not mysteries that punish our ignorance, but syllables in a language we are just learning to speak. We are often told that the universe is indifferent, and it is gloriously so. Yet indifference is the backdrop against which intention, when it appears, shines with the brilliance of a comet's tail in a moonless sky. Whether 3 Atlas is intention or only the pretense of it painted onto our retinas by hope, it performs a service. It drags our imagination into engineering, and it drags our engineering into humility. It says, "Do not merely dream of crossing the abyss with cathedrals of metal. Learn to cross it with equations and patience. Let photons be your engine. Let time be your ally. Let statistics, not stories, shepherd your seeds. But still make stories because the human animal is persuaded by music as much as by math. And the music of a seed ship is a quiet fugue that could rewrite our self-portrait from planetary to interstellar." If in some archive of a far future observatory, a note is kept that on a certain series of nights in the early 21st century, our species watched a thin traveler and briefly suspected its purpose, may that note be filed not under fantasy, but under ignition. An ignition not of fire, but of resolve. The resolve to prepare for the 4th, the 5th, the 100th messenger. The resolve to broadcast back with instruments instead of myths. The resolve to spin from sunlight our own seeds, not to colonize in the vulgar sense of conquest, but to converse, to place a question in the quiet between stars and wait for the patient grammar of the cosmos to answer. In that waiting, we will learn to be older. In that conversation, we will learn to be new.